Math 3, Unit 5, review for the final, Part 2. So we're starting with example L. Yesterday we just went through how to simplify, and today we're going to actually solve. So whenever you're solving with fractions, we need to be careful of what? Your denominator, and that you do not have any what? Extraneous solutions. Okay, so for these problems there's always two things we want to find. We want to find our LCD and then the extraneous solutions. So on this problem, what would be my LCD? Good. X times x plus 2 is correct. And then what are my extraneous solutions? What can x not equal?
0,
Good. X cannot equal 0 or negative 2. And we get that from setting each of these denominators equal to 0. So this one is x equals 0. This one would be x equals negative 2. So if x equaled those values, it would make a 0 in the denominator, which is undefined. And so if my solutions are one of those two solutions, they don't work. Okay? Since I have an equal sign, we can eliminate all of our fractions by multiplying by the LCD. So that's where we're going to go through to every term and multiply by x and x plus 2. Okay, so we're going to go x times x plus 2 to every single term. Okay, so when I do that, the first term, x's cancel out, and we're left with 9 times x plus 2. The second term, the x plus 2's cancel, and be careful of your sign, and that is negative 12x that's left over. And then the last one, the x plus 2's cancel, and we're left with 3x times x, which is good. Okay. Next, we would distribute the 9 through. And so I have 9x plus 18 minus 12x equals 3x squared. From there, you could combine like terms. So 9x and negative 12x makes what? Good. So we have negative 3x plus 18 equals 3x squared. And then which way should I move everything?
to the right.
Good. Because we always want our x squared term to stay positive. So I'm going to move these to the right. And so we have 3x squared plus 3x minus 18 equals 0. Anytime you have a coefficient in front, you want to check to see if that number is first a GCF before you like multiply over and do the diamond. So is each term divisible by 3?
Yes.
Yeah. So we're going to go ahead and take a 3 out, and we're left with x squared plus x minus 6 equals 0. So do we have any values that will multiply to be 1 and add to be negative 6? Good. So we get x plus 3 and x minus 2 equals 0. And when we set this equal to 0, what values do we get for x? Good. X equals negative 3 and a positive 2. Do either one of those values match our extraneous solutions? No. So we have 2 answers for this. So remember how in this test, like you had where there was 1 solution, 2 solutions, no solutions, all solutions? So these are this type of problems, okay? All right, are you guys ready to move on to M? Okay, so what do you think we should do first on this problem for M?
Factor the square.
Yeah, I would factor my denominator to help me find the LCD and your extraneous solutions. And so is there anything that multiplies to be 12 and adds to be negative 8? Good. So I'm just going to cross that out and write it as x minus 2 and x minus 6. So that means that my LCD is what? Good. X minus 2, x minus 6. And my extraneous solutions are going to be?
6 and 2.
Good. 6 and 2. Okay, next step is to do what? multiply every term by my LCD. So multiplying every term by x minus 2, x minus 6. Okay, so when I do that, the first term, everything cancels out, and I'm just left with a 4 equals. Here the x minus 2's cancel, and I'm left with, good, x times x minus 6. And then my x minus 6's cancel, and I'm left with 1 times x minus 2, which is just x minus 2. Am I going too fast? No. Okay, so what's next? Distribute and simplify. Good. Okay, and so we're going to multiply the x through. So I have 4 equals x times x is x squared, x times negative 6, negative 6x, good, plus x minus 2. Then we'll combine like terms, and so I get what?
X squared plus mx minus.
X squared minus 5x plus 2, or I mean minus 2, good. Okay, and then what do I do? Good. Subtract 4 so that it's set equal to 0, because we can only factor if it's set equal to 0. Okay, so what will multiply to be negative 6 and add to be negative 5?
Negative 6.
Good, negative 6 and positive 1. So x minus 6, x plus 1 equals 0. And so what will x equal? 6 and negative 1. And do either of those match any of our extraneous solutions?
Yes, 6.
Good, the 6. So 6 is out. And so my answer is just x equals negative 1. Okay, any questions? Okay, so we had some word problems. And this needs to be a little smaller. Okay. A group of college students rent a large house to live in and agree to evenly divide the $1,200 monthly rent. Initially, there are ex-college students, but then 5 additional college students decide to join the group, causing each college student to pay $40 less per month. Okay, so this is where we are going to set up a balanced equation. So one equation is your initial setup, and then the second equation on the other side of the equal sign is what happens when you have additional college students coming. So let's see if do you guys remember, you think, how to set it up? No? Okay, so if the monthly rent is $1,200 and you have X people, what would you do in order to figure out how much each person pays?
1,200 over X.
Very good. So one side of the equation is just 1,200 divided by X. And if you think about that, like if there are 5 people, you would take 1,200 divided by 5, right? Well, since we don't know how many people, we just put X. Okay. Now for the other side. So 5 more students. So we had X students, and then 5 more joined. So how would we divide that rent?
1,200 over 5.
Good, 1,200 divided by X plus 5, because we have to add 5 people to whatever that value is. Now, when you add more people, does your rent go up or down? Down, okay? This is going to be a smaller number than this number, right? And so in order to balance it out, we have to add the 40, because you want each side of the equation to equal each other. And so instead of subtracting 40, we add 40 there again to balance it, because this number is going to end up being smaller because there's more people we're dividing it by. Is that okay? The other way you could have done it is if you wanted to balance it out, you could have put minus 40 on this side to make it so that this number ends up being smaller. Yes? No? Okay. So this is my answer for A. There's my equation. Okay? And so now we need to solve to see how many college students are actually there. Okay? So I'm going to rewrite this down here on B. So we have 1200 over x equals 1200 over x plus 5 plus 40. So what will be my LCD on this? Good. X times x plus 5. And my extraneous solutions would be,
0.
good, 0, -5. And obviously there's not going to be 0 students, and you can't have negative students either. So those extraneous solutions are kind of a given. Okay, so now what do I do? Very good. Multiply every term times x plus 5. Okay, so on the first one, the x's cancel out, and I'm just going to write that I have 1200 times x plus 5. On the next one, the x plus 5's cancel, and I have 1200x. Plus, and then we just have 40x times x plus 5. Okay, so now I'm going to distribute. So 1200 times x is 1200x plus 1200 times 5. We would do 12 times 5, which is 60, and then add the 2 zeros, right? Equals, and we have 1200x plus 40x squared plus 200x. Okay, do we notice anything right now?
1200x is going to cancel.
Good. Since we have a 1200x on both sides of the equation, we can cancel those out. And then which way will I move things? To the right. Good, because we want to keep x squared positive. So I'm subtracting 6,000 to each side. These cancel out. I have 40x squared plus 200x minus 6,000 equals 0. So again, whenever you have a GCF here in front or a number in front, you want to check to see if all the numbers are divisible by 40. And in this case, they are. So we take out a 40. We're left with x squared plus, and 200 divided by 40 is 5x, right? And then 6,000 divided by 40 is
150.
good, 150. Okay, so can you think of any numbers that multiply to be negative 150 and add to be 5?
15 and -10.
Yeah, 15 and 10, or 15 and negative 10. If you're ever not sure though, remember you could start making a list, so like 1 and 150. And then you could go 2 and 75, right? And keep going through until you can find the numbers that work. Okay, but Noah helped us out, and we got x plus 15 and x minus 10. And so when we set those equal to 0, what do we get?
Was it 10 and -15?
Good, negative 15 and a positive 10. Can we have negative people? No. So negative 15 is out, so that means the answer is 10 college students. Yeah. Hopefully it's a big house.
Yeah, I was gonna
Yeah.
say.
Is that? For that should be good.
All right. Any questions there? Are we good, Jordan?
Yes.
Okay. All right. Another word problem here. Okay. Huck Finn can paint a fence in 5 hours. Tom Sawyer can paint the fence in 6 hours. How long would it take Huck and Tom to paint the fence together? Do you guys remember how to do this one?
Looks like exactly the same as the other one.
Well, you're setting up proportions or
Yeah.
fractions.
Yeah.
Mhm.
Saying was 1 over that.
Yeah, so remember there's one job that Huck Finn is completing and it's taking him 5 hours. Tom Sawyer, same thing.
Whatever, so
Good.
that is 1 over X.
Good, because we don't know how long it'll take them together, and together's on the other side. Okay, and so what would be my LCD on this problem? Good, and anytime we are solving for X with fractions, we want to check for extraneous solutions. And so what would be my extraneous solution on this problem? Good, just 0. Okay, and obviously it's not going to take them 0 hours, right? Or minutes, or whatever it is. Okay, so we're going to multiply every term by 30x. Okay, on the first one, 5 goes into 30 how many times?
6.
So 6x times 1 is
6x.
6x. Plus, the next one, the 6 cancels with 30 and becomes 5x. And 5x times 1 is 5x. And the last one, the x's cancel, and you just have 30 times 1, which is 30. Okay, so what's 6 plus 5?
11.
So we have 11x equals 30. Divide by 11 to both sides. And we get x equals, how many hours will that be? How many times does 11 go into 30? 2 times, which is 22. And there are 8 left over, so it's 2 and 8/11ths of an hour. I think that they're going to leave your answer like that. But could we change 8 over 11 into minutes if we needed to? Yes. Okay, any questions there? All right, last one, graphing. Do you guys remember how to do this? Okay. What do you want to start with? What do you know? What do you remember?
Right.
The line. Okay, what line?
Plus 1, right? Positive 1.
There is a line at positive 1. Is it vertical or horizontal?
It is. No vertical.
Horizontal, good. This is always our y value at the end. Okay, and so if we want to, we can go to horizontal asymptote. And so I'm going to just write HA, and that will be y equals 1. Remember, this is a dotted line because it's an asymptote. It's kind of like our magnetic field that keeps our graphs inside places. Okay, is there a vertical asymptote?
Positive.
Very good. There is a vertical asymptote at x equals positive 2. So remember that whatever's in this denominator here with the x, we'd set that equal to 0, and so that gives us a positive 2. So we have a vertical asymptote at 2. If there was nothing being added here, we would have asymptotes where? At 0. Good. Okay. So how do I find the y-intercepts? Oh, they're not plugged in? Weird. Okay, y-intercepts. How do we find y-intercepts? Very good. So remember with this equation, basically that is y equals. And so we keep the y and we plug in 0 for x when we're trying to find the y-intercept. So we have y equals 1 over 0 minus 2 plus 1. So 0 minus 2 is what? Negative 2. So we have negative a half plus 1. And what would that answer be? 1/2. Good. And if you needed to, we could change, if you can't remember, change 1 to be 2 over 2. And you have a negative 1 and a positive 2, which makes positive 1/2. So as an ordered pair, that is 0, 1/2. And so let's go and plot that. So 0 on the x-axis, and then we go up a half on the y. So there's 1 point. So we can tell right now that there's going to be a curve in that quadrant or that area, right? Okay, how do I find the x-intercept? Good. plug in 0 for y and solve for x. So we have 0 equals 1 over x minus 2 plus 1. Okay, what would I do to solve this one?
Would you subtract 1?
I would multiply by the LCD. So I would do it, you were saying, I think, Haley. And that is multiply every single term by x minus 2. Now, are there other ways of solving this? Definitely. But I'm just kind of sticking to the way we've been doing this unit. What's 0 times anything? 0. So we have 0 equals. X minus 2's cancel, and I'm just left with 1. And then 1 times x minus 2 is just x minus 2. Okay? To solve now, we would combine like terms. Good. So 0 equals 1 and negative 2 makes negative 1 plus x. And to get x by itself, what would I lastly do? Add the 1 to both sides. And so we end up getting x equals 1. So as an ordered pair, that would be 1 comma 0. So at 1 comma 0, I'm going to go ahead and make a point. Okay, so knowing those points, do you guys know how to make your curves? So there's going to be 2 curves, right? Okay, and so 1 is right there on the bottom. And remember, it gets very close to the asymptotes, but it doesn't actually touch the asymptotes. So you have a curve there. And then where would my other curve be?
The opposite of it.
Good, diagonal from that. Perfect. And so this one is up here. So they're always going to be diagonal from each other, the 2 curves. All right, so next we have stating the domain. Domain is dealing with your...
X values.
Very good. Okay, so for my domain then, we're going left to right always when we're reading a graph. And so since I have an arrow going this direction, I'm going to start with what? Very good. Negative infinity. And then if you notice, it goes all the way till I get to 2. And it can't equal 2, so we have a parenthesis at 2. And then it's, remember, it's going to be a union. And it still starts up again at 2, doesn't it?
Mm-hmm.
And then it goes all the way to positive infinity. Okay, so now we're going to go and look at the range. So again, range, we do smallest to greatest as well. So we're going to go starting at the bottom and going up. So at the bottom there, we're going to start with what? Negative infinity. And on the y-axis, we go up, 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 and then there's a break at what? 1, which means it can't equal 1. And then we do the union, and it starts back up again here at 1 again, and goes all the way till positive infinity. Good. Okay, any questions on any of that so far? All right, we already did our horizontal and vertical asymptotes. And so now it asks, state the intervals on which the graph of f is increasing. So when you're reading this from left to right, what do you notice about the graphs? They do not increase, right? You start left and it's going like this and it's going down. And then there's the break, and so you go back up here, and again, do you notice how it's just going down? So what is the interval on which it's increasing?
No solution.
None or no solution. Good. But now the question on the next one states, when is it decreasing? Well, it's decreasing on the entire graph. Do you guys agree? And so since it's decreasing on the entire graph, when you are stating the interval, you're basically stating your domain. Okay? And so it is negative infinity all the way till 2, good. And then the union, and it starts again at 2, and it goes all the way till positive infinity.
Couldn't you put like all reals except 2?
Yes, but the reason why I'm writing like this right now is that this is how it's written on your test. But yes. Okay, and J. When is the function greater than 0? So do you see where it's greater than 0? Good. So above here, this right here is greater than 0. Do you guys agree? And so this starts at negative infinity, and it goes all the way into what value does it cross the x-axis? 1. Okay? And then, do you notice how up here it's also greater than 0? So where is this starting at? 2. But it's not equal to 2, so that's why we use a parenthesis of 2, and then it goes all the way till positive infinity. Okay? So this is above 0, and then it crosses here. So from here to here, it's below 0. And then this whole thing was above 0. Right? Okay? So then it says, the last one, state the intervals in which the graph of the function is less than 0. So it's less than 0 from what to what?
Oh, 1 to 2.
1 to 2. Okay? So the answer is 1 to 2, and if you look at this graph, so when it goes below the x-axis, it crosses at the value of 1, and it continues until it hits this asymptote, okay, and the asymptote's at 2. So that's the only values when it's below 0. Any questions? No? All right.